Hello everyone, this is Dr. Mo Shiva, Professor of Electrical Engineering at California State University, Fullerton. I did one example on mesh analysis. This is the second example. If you have not seen the previous video, please go ahead and check example 1 first and then come back here for the second example. I'm assuming you're familiar with mesh analysis, and this is just a review example. To do a quick review of mesh analysis, for a circuit, we choose mesh currents all going in the same direction, usually clockwise if it's not chosen. We apply Kirchhoff's voltage law to each mesh. The preferred version that I like is to look at voltage drops around the mesh being equal to 0, algebraic sum of voltage drops around the mesh equal to 0, applied in the direction of the mesh current. Another thing that we do, if we have current sources present, we use a supermesh. So in this example, we are looking at voltage sources and a current source. We are using voltage drop simply because that makes everything simple. If we are going in the direction of the current, voltage V across the resistor is Ri. V is Ri, which means voltage drop is equal to resistance times current entering positive voltage reference of V. So we look at the circuit, we have a current source. We cannot apply Kirchhoff's voltage law to mesh 2 or 3 simply because voltage across the current source is not known. So lots of books say combine mesh 2 and 3. We really do not combine those. These are two separate meshes, each with its own current. By combining, what we mean is apply Kirchhoff's voltage law to both loops, to both meshes at the same time. Treat mesh 2 and 3 as a single mesh. Do not look at what is inside of it. So let's give it a try. First, let's start with mesh 1. We commonly make it a habit of starting at one point so we don't miss any of the elements. Lower left corner, we can start there, go around the mesh, write voltage terms, add them up, put it equal to 0, and end up at the same place. So if we look at mesh 1, starting at the lower left corner, first term is 4 times I1 in the direction of the current, positive Ri. We see a voltage source. We are entering its negative side, so simply write it as negative 10. Next, we are looking at 5 ohm resistor. We are moving from left to right in the direction of I1, opposite to direction of I3. So plus 5 in the direction of I1, opposite to I3. We have a dependent source. We are entering the positive, so plus 10 Ix. Going straight down, we have 3 ohms. Going down in the direction of I1, opposite to direction of I2. And finally, we have another voltage source. We are entering its negative side, so minus 10 equal to 0. Then we have the supermesh. Supermesh is meshes 3 and 2. Start at the kind of lower left side of it. So we are looking at supermesh treating meshes 2 and 3 at the same time. First term, on the top we have 1 ohm, so positive 1 current through that is I3. We see the negative terminal of the 3 volt source, so minus 3. Go straight down. We're looking at negative side of 5, so minus 5. Plus 1 ohm in the direction of I2, so I2. We are now turning around, going up through the middle branch. We see positive side of the source, so plus 10. Next, we need to write voltage drop across the 3 ohm resistor in the direction of I2. So make sure that is not confusing. Do not look at that IX. IX is just defined there. We are going up, so plus 3 times in the direction of I2, opposite to direction of I1. So this is an important term. Make sure that IX is not confusing. Just neglect it. Continuing through the dependent source, we see the negative side, so minus 10 IX. And finally, 5 ohm resistor in the direction of I3, opposite to direction of I1, equal to 0. Whenever we look at the supermesh, immediately we look inside the supermesh. In other words, information provided by the current source. And that current source is telling us current going from right to left. In other words, I3 minus I2 is equal to 2 amps. The only thing left is IX. IX shows up in 2 places in the equations, here and there. So let's find IX. IX is current going down in the center branch in the direction of I1, opposite to direction of I2. So we have IX. We're looking at voltage drops because that makes checking for a sign mistake very easy. If you are in mesh 1, for terms involving resistors, do not look at dependent sources. For each resistor, the voltage should be positive something times I1, or we get positive I1 minus another current. Same thing is true for the supermesh. So for supermesh, we should get either positive I3, supermesh is meshes 2 and 3, or positive I2. One of those currents by itself, or I3 or I2 with another current subtracted from it. So if you had made a mistake here, if you had written this as I1 minus I2, we would right away know something is wrong, because this should be positive I2 minus something. Mesh 2 and 3, positive I2 or positive I3. I hope this is clear. So let's simplify this a little bit. Simplify the first equation and we substitute at the same time for ix. So we get 12i1 minus 3i2 minus 5i3 plus 10ix, which is I1 minus I2. So we're substituting for ix equal to 20. Simplify the second equation. We end up with negative 8i1 plus 4i2 plus 6i3 minus 10ix, I1 minus I2 equal to negative 2. So again, we have substituted for ix here. And last equation doesn't change. Let's just write it as I3 equal to 2 plus I2. Now we have three equations in three unknowns. We can use any method for solving three equations in three unknowns. However, last equation gives us I3 in terms of I2. So elimination of variables is a good choice at this point. Let us substitute for I3 in previous two equations. And that gives us 22i1 minus 13i2 minus 5i2 plus 2 equal to 20. And negative 8 for the second equation, I1, negative, 18, I1 plus 14 I2 plus 6 I2 plus 2 equal to negative 2. And simplify those a little bit further. 22 I2 minus 18 I2 equal to 30, and negative 18 I1 plus 20 I2 equal to negative 14. Divide all coefficients by 2 to make this a little bit simpler. We have 11 I2 minus 9, 11 I1 minus 9 I2 equal to 15, negative 9 I1 plus 10 I2 equal to negative 7. Let us find I1 using Cramer's rule. So I1 would be ratio of two determinants, denominator, determinant of coefficients of the left-hand side of the equations, 11, negative 9, negative 9, 10. Numerator, change, since it's I1, change the first column with the constants on the right-hand side. So we have 15, negative 7. Second column doesn't change. Find the determinants, find the ratio, and we end up with the 3, with 3m's. Then we use the second equation here. And that gives us I2 equal to 9I1 minus 7 over 10 equal to 2 amps. And finally, let's find I1. I3. We have I3 equal to 2 plus I2. So I3 is 2 plus I2 equal to 4 amps. The other thing that the problem is asking for is the power supplied by the dependent source. For power, we use passive conventions for an element with current I and voltage V. P is VI, and this really means absorbed power by the element is voltage times current entering positive terminal of V. So for supplied power, we can either find absorbed power and change the sign of it, or we can multiply voltage by current leaving the positive terminal. So let's look at the dependent source. Voltage is 10Ix. For supplied power, let's multiply that voltage by the current exiting or leaving the positive terminal, which is in the direction of I3, opposite direction to I1. So I3 minus I1. So supplied power, and remember, when we say power, we are always referring to absorbed power, so make sure if you are computing supplied power, we write it there. Is voltage 10Ix times current leaving the positive terminal, I3 minus I2. That being equal to 10 times Ix itself is I1 minus I2. Ix is I1 minus I2. So we are looking at 10 I1 minus I2 times I3 minus I1 and notice that I have a mistake there. The current here is I3 minus I1. So let me correct this to I1. That's equal to 10 times, substitute for the numbers, we get 1 and 1. And this is 10 watts. And make sure again you have the word supplied next to it, because we did not use the passive conventions. We did not use the passive conventions. So this is an example for using Supermesh. We have one more example for mesh analysis. That would be the next video. Again, there was one before this example and there is one after this example. So look at those videos to get familiar with mesh analysis.